I work on a small team called the Coastal Digital Elevation Model Team, so the DEM team, and we build digital terrain, landscapes of various places in the world, especially along the coastlines. Both the topography over land near the shore and then the bathymetry going into the shoreline and underwater. And that topography is really critically important for hazard modeling for things like tsunamis and storm surges. When an earthquake happens in Japan and there's a giant wave coming across the Pacific, they spin up these models and they see where flooding is going to happen in Crescent City, Oregon. And they need really accurate elevation models, both in the sea and the land, in order to be able to give those answers and evacuate people. And it saves lives. So we have to get really, really good information. One key factor that we didn't really have as a team up until about 5 years ago was a widespread way to validate these models, to say, all right, how good is our model? How accurate is it? And so since we take all the data we can to build these models, it's really hard without some external data set, some independently measured data set, to figure out how good our models are. And ICET2 fills that better than any other tool we've ever had. We use several of the ICET2 products. They're ATL03, which is their big point cloud product. We combine that with the ATL08, that's their land and canopy surface, because we're interested in where the bare earth ground is. We want to eliminate the trees. And so the fact that ICET2, they've got that built in on the science team's products to pick out where the ground is, what's ground elevations and what's canopy elevations. The users of our digital elevation models that we build, it's actually a wide variety of users, because we do very high resolution local models to full on global models. We had a full global release of an Earth topography data set just a couple of years ago. And the users are our closest users. We work with NOAA offices, for instance, the National Weather Service and the National Hurricane Center. We also work with a lot of state and local level agencies. Cities, for instance, on infrastructure planning, they want new DEMs. If they're going to be building coastal infrastructure, they need to know as precisely as possible where the topography of their area is. And you'd think, well, they live there, obviously they know, but like having detailed maps is not an easy thing to get, and that's what our team specializes in. So the Applied Users Program, since I've joined, we've started making a lot of connections with other teams that are both using ICET2 and also building tools into ICET2. So we're a connection with the team that's building out the ATL24 product and having conversations with them. That's the ICET2 bathymetry product that gets you lake and ocean bottom surfaces and shallow waters that we're going to be using that data. And we wouldn't have been in touch with them if it wasn't for the Applied Users Program. One of the big things that ICET2 does for us that no other data set we could collect does is give us high accuracy, high resolution elevation data around the world, anywhere on the world that we want it. We can be validating DEMs over northern Russia, over northern Alaska, over southern Patagonia. It doesn't matter. Anywhere we are wanting to measure elevations, we can go pull the ICET2 data in that area and get it.